Hi, welcome to section 1-2, Measurements of Segments and Angles. Our objective is to be able to measure segments, angles, classify angles, name the parts of a degree, and recognize congruent angles and segments. This is going to be a 2-day lesson. For the first day, we're going to work on problems 1 through 8 and 10 through 11. On days 15 and 16, we're going to work on problem 9, and then 12 to 22 evens. So here we go. We're going to start off with measuring segments and angles. Now, we have some vocab here. So first and foremost, we measure segments with a ruler. Segments are going to be measured in units such as inches, millimeters, centimeters, things like that. We measure angles, therefore, with a protractor. We measure lines with a what? What do you think lines are measured with? You can't measure a line. If you remember from section 1-1, lines never end. They go in two directions forever, and you can't measure forever. Angles are measured in degrees. Segments are going to be measured in measurement units such as inches, centimeters, miles, and millimeters. Okay, so we have 4 types of angles. Let's name and describe them. So our first type of angle that we're going to have is going to be an acute angle. Now, let's describe what an acute angle is. An acute angle is an angle whose measurement is between 0 and 90 degrees. So it's going to be greater than 0, but less than 90. And then we're going to have a right angle. A right angle is exactly 90 degrees. Our third type of angle is going to be an obtuse angle. For our obtuse angle is going to be measured in between 90 degrees and 180 degrees. So our angle measurement is greater than 90, but it's less than 180. And our last type of angle is going to be a straight angle. A straight angle is going to be measured exactly 180 degrees and forms a straight line. Now we're going to move into talking about the parts of a degree. Each degree is broken up into minutes and seconds, similar to how you would actually measure time. Now, here's what we have. There are a total of 60 minutes in a degree, and there are also 60 seconds in a minute. The symbol that we're going to be using for minutes is going to be one slanted line, and the symbol we're going to be using for seconds is going to be a double slanted line. Now the next thing we're going to do is change from degrees to degree in minutes. Now here's what we're going to do. For the part that's going to become a degree based on our fraction is going to be the whole number. The part that's going to turn into our minutes and possibly our seconds is going to be the fraction part of our degree. So again, the whole number is going to become our full degree. The fraction part is going to be our minutes and our seconds. So what we're going to have here is we're still going to keep 87 degrees. But we have to think about what half a degree is in terms of minutes. So, if we know that there's 60 minutes in each degree, what would we have for half? If you said 30, that's correct. Our answer is going to be 87 degrees and 30 minutes. So for our next one, 60.2 degrees. We want to turn that into degrees and minutes. The 60 part, our whole number, is going to stay our degrees, but we have to think up what 0.2 is going to be. So we have 0.2 of a degree, and if you said 12 minutes, that's going to be correct. Now let's think about how we got that. What we have is we have 0.2 of a degree, so 0.2 times 60 is how we end up getting 12 minutes. So for our last one, 19 3/5 degrees. Press pause and let's check your answer, see how you do. Hopefully you got 19 degrees and 36 minutes. What you're going to take here is you're going to take 3/5 and multiply that by 60, which gives you 36 minutes. For these next problems, we're actually going to work our way backwards. We're going to change from degrees and minutes to degrees only. So what we want to do is write this as a fraction or a decimal. If it's a decimal, it has to be a terminating decimal. We can't use repeating decimals. So here we go. We have 35 degrees, 45 minutes. Now we have to think, how do we turn that back into a fraction? Well, if to turn it into minutes, we had to multiply by 60. In order to go backwards with it, we're going to divide by 60 and reduce our fraction. 45 divided by 60 is going to end up giving us 3/4. 35 3/4 degrees. You try that next one. 18 degrees, 25 minutes. Press pause and let's see what you can do. Hopefully you took the 25 divided by 60 and reduced that. That gave you 5/12. 18 5/12 degrees. Now for our next examples, we're going to find the sum or difference. So here we go. We're going to be subtracting. Now, when you subtract, you actually want to start here on the right. That way, if you need to borrow, you're going to borrow from the column to its left. You want to start off by subtracting the seconds, go to the minutes, and finally end with those degrees. So here we go. 26 minus 15 gives me 11 seconds. 45 minus 32 is going to give me 13 minutes. And 37 minus 29 gives me 8 degrees. 8 degrees, 13 minutes, 11 seconds. Now, for our next one, we're going to do the same thing. We have 18 minus 2, which is going to give me 16 seconds. The next column, we run into a problem. We have 36 minus 54, so our number on top is going to end up being too small, and we can't have negatives. What we have to do is we have to borrow 1 from our degree, leaving me with 83 degrees. Now, when I transfer to my minutes column, we have to think. 1 degree transfers into how many minutes? 60. So when I cross off that 36, because I borrowed that 1 degree, it becomes 96 minutes. And now we can subtract. 96 minus 54 is going to give me 42 minutes. And then 83 minus 36 is going to give me 47 degrees. 47 degrees, 42 minutes, 16 seconds. Now, for our last one, here we go. This one's going to be an addition problem, and it's going to work the same way. Go from the seconds into the minutes over to the degrees. 45 plus 39 is going to give me 84. 16 plus 52 gives me 68. 12 plus 45 is going to end up giving me 57. And we have a problem. We don't have units that are this big for seconds, nor do we have units this big for minutes. Think for a second as to how big it can be before it transfers into the next column. Hopefully you said 60. Now if I take away 60 seconds, that's going to leave me with 24 seconds, but 60 seconds is 1 minute, which leaves me with 69 minutes. 69 minutes, I have enough in this column to transfer it over. I can take off 60 minutes, which is going to transfer 1 degree. 58 degrees, 9 minutes, 24 seconds is going to be my final answer. Now, here's 2 for you to try. We're going to add or subtract 1 of each. Let's press pause and check our answers. Okay, so here's our answers. For our first one, 25 degrees, 25 minutes, 38 seconds. So what we had to do here is we had to borrow. We had to borrow 1, making it 44 minutes, and making this 70 seconds. I added 60, and then we just subtracted going down. For my second one, once I added here, that ended up giving me 81 seconds. That ended up giving me 59 minutes, and that ended up giving me 89 degrees. And I had to transfer them over by taking away 60 seconds, giving me 21, but making this 60 minutes. 60 minutes, I can transfer all of those over to give me 90 degrees instead. Okay, so here are some of the more difficult ones, converting to degrees, minutes, and seconds. So here we go, our first one. We have 18 4/9 degrees. We want to convert it to degrees, minutes, and seconds. So we know we're going to take that 4/9 and we're going to multiply that through by 60. And that's going to end up giving us 26 2/3 minutes. Well, we can't have that 2/3. So let's take that 2/3 and let's multiply that by 60. It's 2/3 of a minute, and we know that there's 60 seconds in every minute. 2/3 times 60 is going to end up giving me 40 seconds. That gives me 18 degrees, 26 minutes, and 40 seconds. You try the next one and let's see what you can do. You should have 102 degrees, and let's take that 7/8 and let's multiply that through by 60, which gives us 52.5. And that's going to be our minutes. Take that 0.5 and let's multiply that through by 60, which gives me 30 seconds. 102 degrees, 52 minutes, 30 seconds for our final answer. For our last one, let's actually end up working backwards here. To work backwards, what we're going to do is, starting over here with our seconds, let's divide it by 60. If we can't write it as a decimal, that's a terminating decimal, let's write it as a fraction. So that gives me 14 degrees and 20 1/3 minutes. Take that 20 1/3 and let's divide that through by 60. So for our next example, we're going to convert to degrees, minutes, and seconds. So here we go. Just like our last example, that whole number is going to represent the total number of degrees. That fraction is going to be converted into our minutes and seconds. So what we're going to do is we're going to take 4/9 and multiply that through by 60. And that ends up giving me 26 2/3 minutes. Now, we don't want that 2/3, but the whole number is going to represent how many full minutes we have. So 26 minutes. Now, we want to work on that fraction of a minute. So we're going to take 2/3 and multiply that through by 60, and that's going to end up giving me 40. You go ahead and try the next one. We have 102 7/8 minutes. Press pause, try it, and then let's check our answer. Okay, so here we go. We know that we have 102 degrees. We take that 7/8 and multiply that through by 60, and that gives me 52.5 minutes. So we know we have 52 full minutes. So then we're going to take that 0.5 and multiply that through by 60, and that ends up giving me 30 seconds. And that's how we're going to convert from strictly degrees to degrees, minutes, and seconds. Now let's work our way backwards. We have it in degrees, minutes, and seconds. We want to go backwards and go to degrees only. So we want to either write it as a terminating decimal or as a fraction. So here we go. We want to start from the right side. We want to work our way backwards. So we want to turn those seconds into minutes, then those minutes into degrees. So the first thing we want to do is divide by 60. What that gives me is 14 degrees and 20 1/3 minutes. Now, we want to take that 20 1/3 and divide that by 60. And that's going to end up giving me 14 61 over 180 degrees. So kind of yucky, but we're going to deal with it. You go ahead and try the next one. Press pause and let's see what you can do. So here we go. Working our way backwards, we're going to divide by 60, and that gives me 52 degrees, 30 4/15 minutes. We're going to take that 30 4/15 minutes and let's divide it through by 60. And that's going to end up giving us 52 227 over 450 degrees. Yuck. Not a nice number at all, but again, we're just going to kind of deal with it. So for our next example, we know that angle M is acute. We want to know what are the restrictions on angle M and on X. Now, we know acute angles are less than 90 degrees. So angle M is less than 90 degrees. But there's another restriction. We can't have negative angles, so angle M is also going to be greater than 0 degrees. Now, in order to find the restrictions on X, all we're going to do is replace angle M with our expression 3x plus 20. So 0 is less than 3x plus 20 is less than 90. Now, when we're solving these compound inequalities, what we want to do is do the same thing to all three pieces. So I'm going to subtract 20 from all three pieces. leaving me with negative 20 is less than 3x is less than 70. We're going to divide everything through by 3, which leaves me with negative 20 thirds is less than x is less than 70 thirds. We can leave those restrictions like that, or we can write this as an improper fraction or a mixed number. What we can't do is write this as a decimal. Next, we're going to do some clock examples. And what we're going to try and do is find the angle formed by the hands on the clock at certain times. Let's start off at 2 o'clock. At 2 o'clock, we have our hour hand is directly at the 2, and the minute hand is going to be exactly at the 12. Now, when we think about a clock is going to be circular, which means it's 360 degrees. And it's broken into increments, and there's 12. Each increment from 12 to 1, 1 to 2, 2 to 3, so forth and so on is going to be exactly a 30-degree increment. So from 12 to 1 is 30 degrees, from 1 to 2 is 30 degrees. So the angle formed at 2 o'clock is going to be 60 degrees. Let's try a more difficult one. Let's go ahead and let's try and find what is formed at 1:30. Now, at 1:30, the minute hand is directly at the 6. But let's think about that hour hand. Every minute that hour hand moves slightly. So, at exactly 1:30, we know that that hour hand is going to be directly in the middle of the 1 and the 2. So we're going to work our way backwards. Here's a 30 increment, 60, 90, 120. Now, we're halfway around the hour, so that hour hand goes halfway in between its interval. So halfway, or 30 over 60, of a 30-degree increment gives me an additional 15 degrees. 30, 60, 90, 120, 135 degrees. We'll work on some more in class, but hopefully this gave you an idea of how we're going to work those clock problems. Last but not least, we have to address a few geometry topics that come up. First and foremost, you have to understand that if angles are congruent, they have the same measure. Congruent segments have the same length. Now, the symbol for congruency is going to be an equal sign with this little squiggly on top. That's what congruency is going to look like. And if we do have congruent things, they have the same tick marks. So if we have angles that are congruent, they'll have this little line through them, or a line with a marking in it. If we have segments that are congruent, they're going to have tick marks as well. Singles, doubles, X's, it doesn't matter, but they'll have the same tick mark. So here are the answers to the 1-2 homework. Now remember, section 1-2 is going to span 2 days. So here's the answer for the first night, here's the answer for the second night. If you have questions, please make sure you jot them down, and I'll make sure we address them in class. Have a good one.